Welcome to this explainer. If you've ever found yourself wondering why machine learning models just suddenly break down or completely fail to do their jobs, well, you are absolutely in the right place. Today, we're going to uncover the two main culprits behind these tech failures. It's this fascinating duality, underfitting and overfitting. Listen to this. Almost every machine learning model that fails in one of just two ways, and they're opposites. I mean, it's so true. When a model breaks, it almost always falls into one of two extreme camps. It's either way too simple to learn anything actually useful, or, on the flip side, it becomes so incredibly obsessed with tiny, irrelevant details that it completely loses the ability to generalize. If you can learn to tell these two apart, you can literally diagnose almost any broken model on sight.
Okay, let's dive into this. To really get it, think of a machine learning model kind of like a student studying for a massive final exam, right? On one hand, you have the slacker who barely skims the textbook. And then on the other, you've got the highly stressed student who literally memorizes the practice test word for word. These two totally distinct study habits actually perfectly mirror our two types of model failures. So first up is underfitting. This is our slacker student. You know the type. They skimmed the material maybe once, learned practically nothing, and predictably completely bombed the exam. In machine learning terms, it just means the system is simply too basic to capture the fundamental patterns in the data, and the tell for this is incredibly easy to spot. If the model performs poorly on the exact training data it just learned from, yep, it's underfit. Now, flipping to the complete opposite extreme, we have overfitting. This is that super stressed student who intensely memorized the practice test, word for exact word, without actually understanding a single underlying concept. So what happens? They totally ace the practice test, but they absolutely bomb the real exam because, well, the questions were slightly different. In this case, the model memorized the noise and just the random quirks of the training data instead of the actual broad pattern. The giveaway here, you'll see near perfect scores on the training data, but terrible, just awful performance on fresh, unseen data. Now, what's really interesting about this is the exact diagnostic tool that professionals literally live by. Seriously, it really just comes down to comparing two numbers, the training data performance against the new data performance. So if it's bad on both, that's underfitting. Great on training, but poor on the new stuff, that's your overfitting. But if you look at the numbers and see just a small gap with incredibly strong performance on both sets of data, congratulations, you have officially found the sweet spot. The best part is fixing these issues is beautifully straightforward. If you've diagnosed underfitting, meaning your model's just way too weak, you simply make the model more powerful, or just train it for a longer period of time. Basically, you make that slacker study. But if you're dealing with overfitting, you actually need to do the exact opposite. You have to simplify the model or feed it more varied data. This forces it to actually learn the big, broad patterns instead of just blindly memorizing the quirks. Ultimately, the whole goal in machine learning is just finding that perfect balance. You want a model that is powerful enough to capture the true pattern, but definitely not so rigid that it just memorizes background noise. Out in the industry, successfully navigating between those two extremes we just talked about, that's officially known as the bias-variance trade-off. Before we wrap up, I want to leave you with a thought that connects this whole tech concept right back to your own life. When you learn something new, which trap do you tend to fall into? Are you the student who barely skims the surface? Or are you the one who stresses out and memorizes the exact wrong details? It's a pretty fascinating duality, right? Just keep that in mind the next time you're learning a new skill or, training a machine learning model. Thanks for joining me on this explainer.